In this video, we're going to be doing an example of a hypothesis testing for proportions. And I'm going to be following the 4 steps that are outlined on this sheet of paper, which you can find linked in WAMAP and which you'll also find in the information section of this video. Let's start by reading the problem. A simple random sample of 1,028 U.S. adults in March 2013 found that 56% support nuclear arms reduction. Does this provide convincing evidence that a majority of Americans supported nuclear arms reduction at the 5% significance level? So we're going to be working on going through the 4 steps for this problem. So starting with step 1, I'm going to define a variable and the null and alternative hypotheses. In this case, we want to know whether a majority of Americans support nuclear arms reduction. So our variable p, we can let p equal the proportion of Americans who support nuclear arms reduction. The question is, in our alternative hypothesis, we would like to know, does this sample provide convincing evidence that a majority of Americans support nuclear arms reduction? In this case, a majority of Americans would mean that the proportion of Americans would be greater than 50%. So our null hypothesis will be that p is equal to 0.5, and our alternative hypothesis is that p is greater than 0.5. Moving on to step 2. In step 2, we want to obtain a sample and collect data. An important and critical part of obtaining the sample and collecting data is checking the conditions. We have 2 conditions we need to check. 1, is the sample normal? Is the sample random? And as you can see in the box here, it's stated in the problem that we have a simple random sample, so yes, that's stated. Second condition we need to check is the sampling distribution normal. We have 2 conditions we need to check there. Is n p0 greater than or equal to 10, and is n times 1 minus p0 greater than or equal to 10. We're given n, that's our sample size of 1,028. Our p0, our null value, that's 0.5. So, as you can see, 1,028 times 0.5, that's half of 1,028, is definitely greater than or equal to 10. And 1 minus p0 is also 0.5, so both conditions are met. I'm going to pause here to continue step 2. Step 2 has many parts, so we've checked our condition, and now we need to calculate the sample proportion and the test statistic. Test statistic is very hard to say. Z. Well, we don't really need in this case to calculate our sample proportion because we're given our sample proportion, which is our p hat, which is 0.56. Our test statistic in this case, z, is given by this formula, p hat minus p naught divided by the square root of p naught times 1 minus p naught over n. Filling in all those values, I have 0.56 minus 0.50 divided by 0.50. 1 minus 0.50 is also 0.50. And I've got this calculation, the numerator, I can do that part in my head. 0.06, 0.50, 0.50, 1028, and I'm going to use my calculator at this point. This calculation, because you've got a complex fraction here, you need to be careful getting that into your calculator. So, carefully enter. And in this case, my test statistic, which I'm going to round to the nearest hundredth because I'm doing this problem by hand using the normal table, my test statistic in this case is 3.85. So let's think about what that means in the context of this problem. So we have assumed that the center of our sampling distribution is 0.5. This test statistic means that our sample proportion is 3.85 standard deviations above that value, which seems very unlikely. So, moving on to step 3. Let's see if what we think that this is highly unlikely to get a sample that's 3.85 standard deviations above that assumed value. Let's see if our intuition is correct. So what we're going to do in step 3 is we're going to find the p-value. There's 2 ways to find the p-value. We can use technology, but we won't be using the technology. We're going to use the normal table. So what is the p-value? Well, the p-value is the probability of observing a sample proportion that's 3.85 standard deviations or more above 0.5, assuming that that 0.5 is the true proportion. So, in other words, the p-value is the same as the probability that z is greater than 3.85. If you look at your normal table, you'll see that 3.85 is off, it's far above the values that appear on the normal table. So that means that our probability of observing a sample that produces a test statistic that's greater than 3.85 is essentially 0. Okay, so from step 3, we found our p-value. Our p-value is 0. Let's move on to step 4. In step 4, we want to make conclusions in context. So, so let's just recall. We can reject our null hypothesis if our p-value is less than our significance level. In this case, our significance level, that's our, we're given the 0.055%, 0.05, so we have that the p-value is less than 0.05, which means we can reject the null hypothesis. All right, let's state our conclusion in context. We can reject our null hypothesis and say that the sample provides sufficient evidence to support the claim that a majority of Americans support nuclear arms reduction.